Hello 108 students, Mr. McHugh back with you here on section 8.6. Hey, taking on page number 2. Going to tackle some equations with radicals that are just a little harder than what we saw on the last page, but my theme for this page is we are not scared of no radicals. Okay, and so look at example 2 here, and you know, I forgot to mention the 4 steps that you saw in the previous class notes. You know, look how I numbered them here down the left hand side, and you can follow the steps going on there, so hopefully that'll help you out. Okay, so I look at example 2 and I see the radical and I go, oh, it's not all by itself, but hey, aren't we always following the principles of isolating the variable? So there's this term, the square root of 5q minus 1, and it's got what, another term on it, plus 3. So what do you think we could do? If we add 3 to both sides of the equation, we've isolated the radical on the left hand side, doesn't matter which side, and we've got negative 3, 0. Oh, excuse me, minus 3. Oh my God, minus on both sides. Apologies, holy moly. So now that's how easy little mistakes can happen. Okay, now you could see I was like, wait a second, that doesn't make any sense. So it always pays to show your work going down there in the details. You can go back and find little negative mistakes if you make them. Okay, so let's get back on track. What do we do now? We've got the radical on the right hand side. We are not scared of radicals, because what can we do to make them go away, class? Square both sides. You maintain balance. That's what step number 2 does. Okay, what happens when you square a radical? What drops down? The radicand. Every time. Whatever underneath the radical, it drops down. And negative 3 squared is 9. And now you've got a mop-up operation. That's why I like doing these. Can you isolate and solve for 5q? Sure. Add 1 to both sides. 5q equals 10. Divide by 2. And lo and behold, q equals 2. And you think you're almost done, but what do you got to do now? Got to check your solutions. Okay, you got to watch this. This is going to burn you if you don't do it. You're going to put 2 in there, and you're going to get an x, and you're going to be mad. You're going to go back and say, it's all right, I didn't make a mistake, and then you're going to realize you forgot the Arrhenius solutions. So check your answer. In this case, when q equals 2, it does not work. 2 times 5 is 10, minus 1 is 9, square root of 9 is 3. 3 plus 3 does not. 6 does not equal 0, therefore it's not a solution. Therefore your answer is the null empty set. Okay, got to watch that. Objective 2 says solving harder radical equations. So we say, okay, and here's the big thing you're gonna watch for, and remember, radical's already isolated by itself on the left hand side. You're like, no big deal, I'm going to square both sides. But when we say square both sides, you must put the parentheses around the whole entire right hand side and then square it like I've shown here. That's the big step to do this. Okay, what does that trigger? Well, on the left hand side, we know the drill. Squaring undoes the square root and it drops the radicand down. There we go, 4 minus x, piece of cake. Now over here, what do you got? Binomial squared. Now how many of you guys can go from here straight down to here? Okay, if you can't, you would do x plus 2 times x plus 2. You'd be using FOIL on multiplying 2 binomials. However, how about this? Take the first term, square it. Multiply the 2 terms, x times 2, and double it. So 2x times and double it would be what? 4x. 2 squared is 4. A lot of you should be able to go straight down to there. If you can't, no big deal if you're a little rusty with that, but it makes life a little easier when you got those shortcuts working. Okay, now I look at this equation and I say, what popped up? Okay, you got a quadratic equation now. Okay, can we handle this? Sure. Go back a few chapters, and what did we do? We put all the terms over on one side. So I'm going to, it says minus 4 minus x on both sides, minus x minus 4, and add up your like terms. There's 0 equals x squared plus 5. Notice that the constant term canceled out. Okay, now we got a quadratic. You know you have 2 solutions. The constant dropped out, so you're not going to use reverse FOIL. But you got to solve for this, and I'm hoping this is the big step you remember. What's the number 1 rule when you factor, class? Please tell me. That's right. Pull out the GCF right here. Pull out the GCF, which is an x, and all of a sudden you got 2 sets of factors, x times the quantity, x plus 5, and then take each factor, set it equal to 0 because you've got to produce zeros to make a 0 on the left hand side. Solve for x equals 0, x equals -5. Go back and check your solutions. Step number 4, don't forget it. And I turn around and I put 0 in. Turns out to be a true statement on the equation, so that is a solution. Put -5 in, and I'm rushing through this, but you could follow the details here. And you find out the left side does not equal the right side. +3 does not equal -3, so therefore this is not a solution. You're only left with one solution, and that is 0. Not the null set, but the number 0. Okay, so we're doing pretty good here. I squeezed another example in here real quick. They gave you a trinomial underneath the radical. I squared the left side, and I'm going to square the right side, the whole quantities, the whole sides. The radical drops down, x minus 1 quantity squared. Again, you've got a perfect square trinomial. Take the first term, square it. Multiply the two terms, x times -1 is -1x, and double it's -2x. Take the second term and square it. -1 squared is a +1. Now you've got lots of terms over here. What I like to say in class, look at the x squared and look at the x squared. Now you can decide to move this guy over and say minus x squared. Another way to look at this is when you see the exact same term on both sides of the equation. Now hear those words. When you see the exact same term, that means sign, exponents, bases, you can in essence cross them out because they cancel. That's because when you minus x squared on both sides, look what happens when you combine like terms. There's your big fat 0. So now you've got -2x, add 2x to both sides, +1 minus 1 on both sides, leaves you -2 plus 2 is -2x equals -8. And divide by -2, watch the difference, watch your signs, and x equals negative divided by negative. Bingo, 4. Put it in, check it out, and you got it. So your solution set to this problem is 4. Okay, Mr. McHugh here. Hey, we're rolling through 8.6. Got 8.6 page 3 to work on next, so I will see you then. Okay, take it easy. Bye.